Hi everyone, in this video we are going to cover part 2 of the screenshot application series. I hope you have already watched part 1. If not, I highly recommend going back and checking that out first because it will give you a better context and understanding of what we are doing here. In this part we will take a look at the overlay box class. It was originally just a function, but I turned it into a class to make it more flexible and modular. The image preview class, which helps us preview captured image, and a few other important functionalities I have added. Finally, by the end of this video, I will show you how to use InnoSetup tool to turn your Python code into a real installable desktop application. So let's get started. So as you can see, the UI has changed quite a bit. I have updated the start UI function and refactored the project to use multiple classes for better organization. For example, the screenshot manager class now contains all the logic related to the capture UI, like what should happen when a button is clicked or when a screenshot is taken. If you have watched the previous video, you will recognize that screenshotmanager.py was originally just a file with functions. I have now wrapped it into a class to make it easier to manage. On the UI side, I have added two new components. On the left, we have an image preview class. On the right, we have slide bar or thumbnail container where all the captured image appear as small thumbnails. When you click on a thumbnail, a scaled down version of that image will be displayed on the canvas. To manage these parts, I have created two variables. Thumbnail container. This refers to the right side frame. Every time you capture a screenshot, a thumbnail is added here. Second, a preview canvas. This is an object of image preview canvas class and it handles showing the preview on the left side. Both of these are passed into a screenshot manager class. I hope this structure is easy to follow. Now let's take a look at image preview canvas class. This is the section on the left side of the UI where your captured images are previewed. This class exposes a canvas widget which we are going to use inside our main UI. All the logic related to the image previewing, image dragging and exporting it kept inside this class so it's modular and easy to manage. When we create an object of this class, we pass the parent frame inside the constructor. It creates a canvas and adds it on the frame. We also initialize a few important variables here, a list to store image reference, a list to store canvas IDs, a dictionary to map each canvas items to its original full resolution image. This setup helps us render small versions of images on the canvas while still keeping the full image in the memory for exporting later. Now let's look at add image function. The purpose of this function is to take a full resolution PIL image, create a smaller thumbnail version of it, and then place that thumbnail on the canvas so user can see and move it around. So let's break it down step by step. So step 1, make a copy of the image. We start by making a copy of the image. This way the original image you pass to the function stays untouched. We will use this full version later when exporting. Resize the image, create a thumbnail. Next we shrink the image to 50% of its original size. This makes it easier to display on the canvas without taking too much space. We uses Langkos resampling for high quality downsizing. Step 3, convert to Tinker image format. Since we are using Tkinter, we need to convert the PIL image into a format that Tkinter understand, and that's what image.tk.photo image does. Step 4, add image to the canvas. Now we add the image to the canvas at position 50-50. The anchor and W means we are positioning it from the top left corner. Step 5. Store reference. Now we store the TK image reference to prevent it from getting garbage collected. We also keep track of the canvas item ID and link it to the original full image using a dictionary called image meta. Step 6. Right click to delete. Finally, we added a right click event. If the user right clicks on the image, we remove it from the canvas. One more thing we have to remember, we pass the preview canvas object to the screenshot manager. We use this add function to add the images when thumbnail is being clicked. So let me show you. Here is the place where we are adding the image when the thumbnail is being clicked. So in short, this function handles thumbnail creation, adds it to the canvas, store all the necessary metadata, and allows for basic interaction like deletion. So it's the core of how our visual editor manages images. Now let's take a quick look at remove image function. This is responsible for deleting an image from the canvas when the user right clicks on it. Here is what it does. It first checks if the image exists, finds its index, and then removes it from the canvas and from all the internal lists, including the thumbnail list and the full size image metadata. Clean and complete removal. This keeps our canvas and memory clean and makes sure nothing breaks if the user removes an image. Now let's look at export canvas as image function. Now let's talk about what's happening behind this sense, this export function. This is the brain of the whole image stitching feature. So it's important to understand it properly. Here is what we are trying to do. The user places multiple images on the canvas. They can drag them anywhere, overlap them, or even leave gaps. Now they want to export everything they see into one single big image, not screenshot, not thumbnails, the real full quality images. Here is the challenge. The image are scaled down and they can be placed anywhere on the canvas. That means we don't know ahead of time how big the final stitched image should be. It's not like we can say width is 5000, height is 5000, done, because every layout is different. Some images might be really far apart, others may overlap, so we can't just stack them or add their sizes. That would mess things up. So here's the clever idea. Instead of guessing, we calculate it based on where the images are actually placed. Think of the canvas as a miniature version of much larger space, like a map, where everything is scaled down to fit the screen. What we do in this function is reverse that. We go from minimap, the canvas with thumbnails, back to the full scale world, a giant high resolution stitched image. Let me show you step by step what we are doing here. Step 1, we find out where each image is on the canvas. Each image on the canvas has an X and Y position. Let's say you dropped one at 50-50. Step 2, we calculate where the full-sized version of that image would be. Now remember, those images on the canvas are smaller version, maybe 50% of the real size. So to get the real position of the full size image, we reverse that scale. We take the position and divide it by scalar factor. 50, 50 becomes 100, 100. That tells us when we build the final image, this full size image should be placed at 100, 100. Now step 3. We do this for every image and figure out the total size needed. We repeat that for every image and then look for the furthest edge and the image that goes furthest to the right and one that goes furthest down and the one closest to the top left. This gives us the boundary box, basically the minimum and maximum position that defines the total area all the images occupy. Step 4. We create a blank final image of exactly that size. Now that we know the width and height of the final full stitched result, we create a blank image in memory like a big sheet of paper. Step 5. We paste all the full size image into a blank sheet. Each image is placed at the exact position it was on the canvas, but adjusted so that the top left most image becomes 0, 0. We do this by subtracting the top left image's coordinate from all others, so everything shift into place neatly. The final result, and just like that, we rebuild your canvas but in high resolution using the full original images and saved it as one big exportable image file. No quality loss, no wrong placement, just a clean, stitched up version of your work, ready to saved or shared. So next time you export, just know it's not just saving what you see, it's actually doing some behind the scenes geometry and smart resizing to make sure everything is perfect. Now let's go through the code step by step. First, we check if there is anything to export. We start by making sure there is actually something on the canvas. If not, we just show a warning and exit early. Set up scaling values. Now remember when we added thumbnails at 50% of the real size? Here we set that same scale to reverse it later. The scale factor lets us optionally scale up everything if needed. Loop through every image and calculate its position plus size. For each image, we get where it is on the canvas. Then look up the original high resolution version from our stored dictionary. Then we figure out where to place it on the final image, converting canvas coordinate to real world coordinates. We now calculate how big the final stitched image needs to be. This is based on the position and size of all the full images. We then create a big empty image with a black background where everything will be pasted. We take each full-sized image and paste it onto the final canvas at the exact location it appeared in your preview. This part is like assembling a jigsaw puzzle but programmatically. Once we have built the final image, we either save it to the given path or open a file dialog to ask the user where they want to save it. After saving, we show a confirmation so the user knows everything worked. So I hope you understand it. Think of this function like a camera that takes a screenshot of your canvas but in full HD using the original images. It's not just saving what you see, it's rebuilding it behind the scenes using the best quality possible, and that's what makes this function so important. It's what lets you go from preview to final product. So now let's talk about this class called overlay box. If you remember, this used to be a function, but then I make it a class to add all the functionality related to the overlay here, like dragging, moving, etc., like the green box that you have seen before. The main idea behind this class is simple. Create a draggable, resizable box that lives independently on the top of your main app window. That's why it uses tk.top level, which is like opening a mini window on top of the main one. We remove its border and title bar using override redirect, so it looks like a clean box, not a rectangular window. We also set it to be slightly transparent using alpha and give it a green background to make it visible as an overlay. Now let's look at what it can do. You can click and drag the box anywhere on the screen. It keeps track of your mouse position and moves smoothly based on your dragging. This is great when you are trying to define a specific area visually, maybe to crop or highlight. There is also a small square in the corner. That's our resize handle. When you drag that, the box gets bigger or smaller, just like resizing a window. It won't go in it won't go below 100 by 100 pixels, so it's always stays usable. This makes it flexible for selecting any size area from a tiny thumbnail region to almost full screen. There are also some nice utility methods like bring to front keeps the overlay always on the top. Focus overlay gives it keyboard or UI focus, and .deconfig hide or show the window without destroying it. Get geometry, get the current size position, dot destroy, clean it up when done. These make it easy to control the overlays life cycle from the outside of the class. Like if you want to temporarily hide it while capturing something. And I hope you know the dragging, etc. If not, let me give you a quick overview. Alright, let me quickly explain how dragging works. In this overlay, all the dragging is handled by these three functions: start drag, do drag, and stop drag. Let's look at what this start drag is. This runs the moment you press the mouse button on the overlay. Here we are starting the drag and saving the exact position where the mouse was clicked. That becomes our reference point. Do drag. As you keep dragging the mouse, these functions keep running. We check if dragging is active and then calculate how far the mouse has moved compared to where it was started. That difference we call it dx and dy. This tells us how much the overlay should move. We apply it using .geometry to update its position on the screen. As soon as you release the mouse button, dragging stop. We just set the flag to false. It even avoids dragging when you are clicking the resize handle, so everything feels intuitive for the user. Now let's look at how to build some keyboard shortcuts. Okay, like we want to hide this long screenshot capture window and want to take a full screenshot of the full screen. We can use these screenshots. We are using .bind to attach specific keyboard combination to actions, and we are doing this on the overlay window. We bind all our shortcuts to the overlay. So like the overlay.get widget is going to give us the overlay window. This makes sure the overlay window is listening for key events when it's focused. Now let's look at the shortcut list. This is for Ctrl+C to capture the current screen region, Ctrl+S to finish and save the long screenshot, Ctrl+Z to undo the last captured part, Ctrl+A to start the auto scroll capture mode, Ctrl+M to minimize the control window. Now let's make this app real installable application. For this, we are going to need two main tools. First, PyInstaller, and second, Inno setup. So let's look at PyInstaller. PyInstaller converts your Python script main.py into a standalone .exe file. This means your app can run on any Windows system even if Python is not installed. We use this command to generate the .exe file. Let me explain you the flags. Dash dash one file packs everything into a single .exe instead of a folder with many files. Dash dash no console hides the terminal window, perfect for GUI apps made with Tkinter or PyQt. So now we get a clean .exe file ready to be used by real user. Now what happens when you run the PyInstaller? PyInstaller creates three main things. First, a dist folder. This is where your final .exe file will be placed. Inside this folder, you will find this .exe file, and if you are using some assets, you can put them here. This main.exe is your packaged standalone app. It includes your Python code and all the dependency. You can now double click this .exe and it will launch your app without needing Python installed on the system. Second, it's going to create a build folder. This is a temporary build folder. It contains a bunch of internal files used during the .exe creation process. It looks something like this. You don't need to touch this folder. PyInstaller use it under the hood and you can delete it after you are done. Third, it's going to create a main.spec file. This is an auto-generated config file. PyInstaller creates this .spec file the first time you run it. Like here you can see main.spec. It tells PyInstaller how to package your app. You can edit this file to customize things like adding extra files, icon, or bundling hidden imports. If you want to build again later using this file, you have to just run pyinstaller main.spec. and that's it. Now let's run the Inno setup. Now download and install Inno setup from its official site. This is a free tool that builds an actual Windows installer, a .exe installer file like the ones you see when installing other software. Once installed, you can use it to package your PyInstaller. .exe file can create a professional installer. So let's go through this step by step how to create an installer using Inno setup. So let's first install the Inno setup, download and install it from the official site. Once it's installed, go ahead and open the Inno setup compiler. Click create new script file using the script wizard. You are going to see some options appearing. Just click next and move. Step 2. Now you have to write the .iss file and detail of your application. You will now enter some basic details about your app. Here is an example of your .iss file. Let's see what each part does. Here you have to give your app's name, your app's version, default dir name, default installation folder inside program files. Choose the default install directory like pf/screenshot app. pf stands for program files. Output dir where the installer file .exe file will be saved. Output base file name, name of the installer. Compression makes the installer smaller. Solid compression groups file together for better compression. Now this files section tells setup what files to include like source directory or the app, the main.exe file. This includes your pyinstaller build.exe inside the installer. Now in the icon section, this part creates a desktop start menu shortcuts, screenshot app, shortcut to run your app, and uninstall screenshot app. This is going to create a shortcut to install it. So just to recap, we use PyInstaller to turn your Python code into a .exe file. We use setup to turn that .exe into a real installer for the user. The .iss file tells setup where your file is, where to put it, and how to package it. Now let's compile the installer. Once you are finished, the wizard setup will generate the script. All you need to do is to hit the compile button. It will process for a few seconds and then boom, the installer.exe is ready. You will find it in the folder you selected earlier. Now you have got a full Windows installer just like any professional app. You can share it with others, install it on any PC and it works without Python or any kind of setup. And just like that, if your Python project becomes a real desktop app with an installer and everything. And in future, we are going to add some more functionality, like we are going to try to add how to screen record the video, but it's going to take time. So if you like this video, please like and subscribe and share.